All right. Hello, everyone. The three of us are going to talk about video. We have 25 minutes. We decided to just play 25 minutes of a video on YouTube. Well, no, maybe 25 minutes in Mathematica? No? Okay. No. We are actually working towards having real video processing and analysis in Mathematica, but we are very far from actually getting it. We were excited enough, or we had enough at least, to share what we have come, or how far we have come so far and what we have with you this year. And hopefully next year we have a lot more to show and then maybe release experimentally. So this is, as we wrote here, this is an experimental stage. The goal is to be able to connect to video files like we have been connecting to many other file formats. Stream them, support a lot of formats. I think we have been supporting 2 or 3 video formats with a very poor support for elements and what can come in. So import-export is already a huge part of this project that Piotr is going to talk about. We obviously need to have a player so that we see what is coming in from the video file and what we can do with it, maybe play whatever is happening as far as processing and analysis. And then obviously the strength of Mathematica should be utilizing all of the processing and analysis capabilities on the video files. So for those of you who came to my talk on Wednesday, bump it up. Better? More? More? No, it is 150 now. Is more gonna work with your slides? We can go back. So there are a lot of video files around us, all of our cell phones, a lot of action cameras, GoPros, security cameras. From medical procedures, we get video streams, microscopes, and a lot more devices that are capturing the world around us into videos. There are a lot of services like YouTube and now Twitch for live CEOing and things like that. There's a lot of content that people would like to analyze. We were having some discussions with the attendees. Wouldn't it be nice to do either audio, video, or combination processing to say, what did I say with person X 5 years ago at the tech conference in Champaign, and be able to analyze that or even find that in the so many files that we have sitting in our hard drives. And obviously this, we know we already see a lot of applications for video and video processing in the world of medicine, material science, security, auto industry, video games, and the list just is very long. I'm not going to go on. What we think we can provide or would like to provide is an extensive format support, obviously a video object, as I said, to be able to get a handle and see what's stored, and then computations on separately video, separately on audio, or the combination. And we are aiming for a very strong processing and analysis support, kinds of the applications that we have in mind, or at least are very easy to relate to, are you have noisy video, you would like to stabilize it or get rid of the noise. You would like to track objects, find objects, recognize what's going on, find people, find segments that are correlated, maybe even try to see if the audio and video are correlated, or try to do analysis on the combination, reenactments. And it would be very nice if we could get, I don't know, snippets or album of the year from all the videos that we have. So the goal is big. It's going to take us a very long time to accomplish probably something that is very rich. But we think we are the tool that can achieve that. So we are taking steps towards that. Piotr and Chien-Yu are going to show you details of where we are at now. And if we have time, hopefully we will. We would like to hear any feedback for what we should consider for the first steps that maybe we haven't thought about.
All right, so let me start from import. Again, this is, we are using prototype build. This is not available in 12 and will not be available in the released version of 12.0. So that's why we decided not to put that notebook for you. We're not sharing that notebook. Okay, so we are considering in the first release to add these 4 new import-export formats. We think that they are the most popular that we can support. So MP4, Matroska, WebM, and bit maybe OGV. So quickly, let me show you what we already have in our backend. Basically, we are now working on the backend, and probably not. It's not a surprise for most of you that we will be using FFmpeg library as a backend. So whatever you see right now, it's based on the FFmpeg. So first of all, we have quite a long list of available containers. So this is basically equivalent to what we call formats in import-export. However, I mean, there are many formats that are not really popular or used, even though the FFmpeg supports it. So this is, I think you should be quite happy with these 4 new formats, well supported, and you can start using them hopefully soon. So the containers, and also we have a notion of containers, but in the container you can store various data using video, audio, and subtitle codecs. So let's start from the video decoders. To decode any video stored in a video file, you need various decoders. Again, we have a list of various decoders for video, including the one that are quite standard, like H.264 or hopefully will be supported on all platforms. Similarly for audio decoders, again a long list of various audio decoders, including MP3, MP4, and so on. And also, we want to support subtitles. You can store subtitles in your video files. They could be also stored as in a text file, but now I'm talking about the formats that can be stored directly in the video file. So these are the subtitle decoders. All right, so let's start from metadata. What kind of metadata we can import from video files? So I'm starting from opening a video file. I get a handle to my video, and then I pass that handle to read video properties function, and that's what I'm getting. So encoder, title, encoder, creation time, location, approximate duration. Why approximate? I will speak about this in a minute. Then bitrate, and the next 3 are the most important. So first we see the video tracks. This video file contains 1 video track, and here we have a properties like frame rate, codec, image size, language. Similarly for audio tracks, when you click on that, you have a channel count, sample rate, codecs, and so on. And finally, this particular video file stores 3 different subtitles. All right, so that was the reading the properties from video files. So I mentioned that approximate duration. Basically, to get the accurate duration, unfortunately, this is very expensive. You have to decode every single frame. So for that not very long file, less than 2 minutes, it takes right now 4 seconds to decode this. But well, only for the first time we do caching. So next time you decode it, it's immediate. And well, so that's frame count. Frame and duration are pretty much the same. properties, right? So this is again, once one is computed, the other one is cached, and this is all immediate. So it's only a matter of it's an expensive operation only for the first time. Similarly, we can read the duration of the audio track and subtitles track. Video data, so that's the most interesting part, right? So I'm reading the first 50 frames from that video file and storing this in a manipulate. Audio data, again, we can read the audio and store it in our audio object. Let's see if that works. It doesn't. Well, I guess we have. Right, maybe. There is. Oh. So it does work. We have multiple devices here, audio output devices, and that's why we had issues here. All right, so audio data, then the subtitles, you can think about this as a first, we're reading as a header data, so that's more or less how the header data for subtitles could look like, and then the actual text data for, this is, as you can see, it's maybe hard to parse. It's a raw data for bigger. You're welcome. All right, so that's more or less all what I want to say about import. Quickly about export, and I will let Chien-Yu to show you the player. So similarly, as you saw the decoders for import, we have also set of available encoders for so that you can generate video files using these encoders. 78 here, and corresponding audio encoders, and again subtitle encoders. So here in this example, I'm showing how to generate the Matroska video with video stream, audio stream, and subtitle stream. So once I generate this file, it may take a few more seconds. Then we can read the properties, and you should be able to see that it contains one video track, one audio track, and one subtitles track. So we already have the functionality of reading all of these three properties, all the tracks stored in the video files. And quickly about transcoding, we can convert between video tracks efficiently, so that we're not loading all the data into memory. This is done by FFmpeg efficiently. So we're just passing the handle to the video file. We just specifying the output of the path to the output file, video codec, video container, video codec, audio codec, and well, subtitles. In this particular container, MP4 does not support embedded subtitles, so we don't specify subtitles. But that does work, and actually it shows you this is the which frame is. That's how fast we can now transcode the frames in this video. And once this is done, again, you can see that our output file, the MP4 in this case, contains the video track, audio track, but no subtitles. All right, so that's all what I wanted to say about import-export. Now to Chien-Yu to show you how you can play the video in Mathematica.
Hello? Sure. Okay, so motivations. I assume that's pretty obvious that you only see what you get. If you don't see it, you don't believe it. So another motivation was, since we're pumping from the decoder all the way up to the front end, there's a lot of data to move around. So we have to make sure that it works fairly well. So functionality, we have multiple audio video track. We can have subtitle. So for the multiple audio video track, those are usually used for, say, if you have different angles, that would be your different video track. Audio, usually people put commentary in one of the track. So that's that. Subtitle, if you're a foreign language speaker, that's good most of the time. Video effects, that's the one where we shuffle in the filters in between the input and outputs so that you can create different visual effects to the stream. So let's try this. How do I get next page? Up. There we go. So there we go. Hopefully this works. Oh, I'm missing. Yeah, it's my application. How do I? There we go. That you will see everything.
On the right side, you can see. But guess what?
So that is what it looks like right now. We can choose different track of the audio.
Proof begins to realize here that he has
So
made a
in this
mistake
case,
when
we
he
only
let
have one
Emo
video
into his
track, so
reality.
it's not showing as a tab.
He tries to get rid of him.
As a button.
And to
But we
reverse
do
the
have
damage,
different
but of course
subtitles.
it's too late. The machine won't return to its former state, and without a mind to share his fantasy with, there's nothing.
About this. So then we also hook in a couple filters for now. So edge detect, you can see the movie in edge detection. What else do we have? We have Gaussian blur. So yeah, so it's a basic standard video player with visual effects. So what's next is more like, this is actually how we can hook up different filters in the input. Which one? Command shifts. What's my shifts? E. Well, you're going to see a lot of dynamic modules. It's not. Yep. Yeah, it's going to be some sort of box. I'm sorry. Well, at this point, because everything we play right now, once you play it, it's discarded. So because there's a lot of data to keep track. So this, what you're seeing, is most likely going to be the video stream that we are going to have. See if I can get this to work. So I'm sitting on my filter, and I'm opening up a player device. And I say to play, if you look at the image, you'll see the image. Once you apply the filter, so in this case, I'm swapping the second and fourth quadrants. So those are filters directly in the FFmpeg filters, and you just have to parse it and send it to the input. So also, well, let's try another filter. So in this case, I was trying the dog vision. We actually have this in Wolfram Alpha. So what you do is dog can only see two colors, the yellow and the blue, and they don't have a 20/20 vision. So if I apply the same filters and I look at, oh, that not, oh, there we go. If I apply the filter, then this is what your dog would see if they're watching a movie. So all those filters are done on the lower level with the FFmpeg. We can also try better. Oh, there we go. Am I using the same stream? Yeah, sure. So let's try this. In this case, I'm applying directly on top of the frame that you'll be seeing. So I can basically, it's a plus n, and I'm changing the ends. So those are basically the video stream that we'll be trying to put in, where you can just control it. Yeah. So that's basically what we have for the players. And we can pause this. It's paused.
Yes. Yes.
Right. I mean, from import or in the player, you mean? Just yes. I mean, right. Yes. We may even get to the point that you may specify and import only one channel of audio if that's what you are looking for. Definitely, you can get the audio with all the channels. Yes, we support arbitrary number of channels in audio objects.
But something to consider for our audio formats as well. Just get one channel.
Right.
Or something.
Yes? Everything what is available in FFmpeg just support it. Well, I mean, we will be distributing the packlet, whether we create system functions with this functionality that
You mean the filters? And more. Yeah.
Right, but you saw that there are hundreds of different containers which are hardly ever used. So in a sense, it's not really worth it probably to create a new format from them. But it's obviously available, would be available from the packlet.
Does FFmpeg use GPUs?
Well, we have hardware accelerators are available through FFmpeg, and yes, we will try to have them. It's the issue is then that how do you get that efficiently once your data is decoded on GPU? It should be go directly to your screen, not back to the kernel, because you're losing a lot of performance if you want to have your data back to the kernel and then transfer it using Matlink to the front end. So this is a difficult task. If you have your decoded video data on GPU done through the GPU driver, and then display it directly on your monitor, definitely not the first release of video.
Any other questions?
Yeah. I assume all the filters also run actually with this,
FFmpeg. Well, not the last one was actually, if you see, this is this $current frame is the image, current image that we decode, and we adding the floating point number to it. So we just this is top level mathematical already. It's not using, but this is simple operation. That's why it was smooth.
The edge detector or something. It's gonna be laggy, but.
Because I mean, DirectX also integrates
Well, but that's FFmpeg takes care of that lower level backends for us. We're working on a higher level already. Well, DirectX is again that Windows specific. We want to have the cross-platform and right.
Yeah. I guess the handle to the video stream and then processing is gonna be the same. For player, I'm guessing we're gonna be having an easier time on the cloud to play video. Yep.
I hope so.
I think
yes.
so. I think really as I started the talk, we don't want to build another player. For me, it makes sense to roll out the import-export capabilities before video comes out, but it doesn't make sense to release a video player without having rich processing capabilities or analysis capabilities. So I think encoders are going to be coming very soon, if not with the first release of the video. All right. Any suggestions, please let us know. We got to wrap up for the next talk, but we're going to be outside.